Here we have the integral of 1 over x squared plus 4x plus 5. Notice this is 1 over a polynomial, so one way to solve that is to complete the square. So what I'm going to do here is completing the square, and then I'm going to try to use trig substitution. So I'm going to take the dominator, which is x squared plus 4x plus 5, equal to, I'm going to try to complete the square of that. So I think that's going to be equal to x plus 2 square. So that's going to be equal to x squared plus 2 multiplied by 2 multiplied by x, and then plus 2 square. That's going to be equal to x squared plus 4x plus 4. Now notice this is the same in this side. However, we have 5 in here, we have 4. So I'm going to add plus 1 to the right side. Now the right side is going to be equal to x squared plus 4x plus 5. Now the left side is equal to the right side. So this integral can be written as the integral of 1 over, and then the denominator is going to be equal to this term here, which is 1 and then plus x plus 2 square dx. Now I want to use trig substitution. So how I'm going to do that? We have sine substitution, we have tangent substitution. So notice this is the form of this form here, a squared plus x squared. Therefore, I'm going to use tan substitution. However, our x is not alone. Our x is x plus 2. Therefore, the substitution is going to be equal to x plus 2 equal to a. A here is equal to 1, and then tan of theta. So that's going to be equal to x plus 2 equal to tan of theta. Now I'm going to take the derivative of that, so dx is going to be equal to, then the derivative of tan, it's 1 over cosine square of theta d theta. Now I'm going to take the integrand here and try to write it using the tangent substitution. So we have 1 over 1 plus x plus 2 squared. That's going to be equal to 1 over 1 plus, and then x plus 2 is just tan of theta, and that is squared. So we have tan square of theta. Now I'm going to use tan of theta equal to sine of theta over cosine of theta. So that's going to be equal to 1 over 1 plus, and then sine of theta plus cosine of theta all square. That's going to be equal to 1 over 1 plus, and then I'm going to distribute the square. So we'll have sine square of theta over cosine square of theta. Now I want to make this into one fraction. Therefore, I'm going to multiply this term in here by cosine square of theta, its denominator and its numerator. So this is going to be equal to 1 over, and then 1 multiplied by cosine square of theta, going to be cosine square of theta. And also I'm going to multiply its denominator, so it's going to be the same. And plus sine square of theta over cosine square of theta. Now that's going to be equal to 1 over, and then I'm going to make that into one fraction. So that's going to be equal to cosine square of theta plus sine square of theta over cosine square of theta. Now notice cosine square of theta plus sine square of theta from this identity in here is going to be equal to 1. So this is going to be equal to 1 over, and then 1 over cosine square of theta, and that's going to be equal to cosine square of theta. Now I'm going to take the integral, which is this one in here. So we have the integral of 1 over 1 plus x plus 2 square dx. And then I'm going to use now tangent substitution. So that's going to be equal to, and then notice this term in here, which is this term, it's equal to just cosine square of theta. And then dx just going to be equal to 1 over cosine square of theta d theta. Now we can simplify this. So this term will go with this term. So we have the integral of 1 d theta. Now the antiderivative of that going to be equal to theta plus c. So now what we did is we take the integrand and we simplify it, and then we take the integral and simplify it, and then we need now to back substitute the function of theta. So to do that, I'm going to use the substitution in here. I'm going to solve for theta. So theta going to be equal to arctan of x plus 2. Therefore, going to be equal to arctan of x plus 2 plus c, and that should be the antiderivative of the given integral.